let us start with this model 3. So in model 3, types of support, types of loads, statically determinate and indeterminate beam, support reaction for the statically determinate beam, friction, types of friction, limiting friction, law of friction. So this model 3 is totally subdivided into two parts. One is depending on the types of support reaction, and next is the friction. So up to here it is other part, and from friction it is other part. Friction, types of friction, limiting friction, law of friction, static and dynamic friction, impending motion on the horizontal and inclined plane, wedge friction. So these are some related to friction topics, and up to this, that is a support reaction or for statically determinate beams. Up to this the chapter covers about support reactions. So let us in this video we will finish off types of support. There are four types of support, mainly classified into four types. First one is simply supported beam, sorry, simply simple support. First one is simple support, next is roller support, next is hinged support, fixed support. So now question arises, what are these support, where these supports are used, what is the necessity of these supports. So we will see all those things. Next is a simple support. What is a simple support? A body is in contact with another body, or a body placed freely on a support forms a simple support. Next point is restraint, restrains movement. This is not a movement. Okay, there is a difference between movement and movement. Movement is nothing but a motion of a body from one place to another place is called as movement. This movement is entirely different thing. So this we have already defined in our previous videos. So restrain movement is nothing but motion of a body from one position to another position is called as movement. There is a difference between this movement and this movement, okay, of a body in a direction normal to the contact surface. Simple support. So once again I will define: a body in contact with another body, or a body placed freely on a support forms a simple support. And another property of the simple support is restrains movement of a body in a direction normal to the contact surface. Now let us see, see into some pictures. See, this is a body and it is placed over some simple support, like maybe it may be a table or a ground or whatever may be. This is a support and this is the body. Oh, this body is placed over this support. It is just placed on this body. So this is the weight acting in the downward direction, to which a reaction that is developed in the upward direction, so that this body will not fall down. If it is a table, let us take this support is a table. If this support is a table, what happens? This body will not fall because of this support. Okay, so this support is producing an support reaction in the upward direction, that is normal to the support. Okay, see here what is defined here: restrains the movement of the body in a direction normal to the contact surface. Right, this is the contact surface, this surface is the contact surface, and it will not, and the reaction developed is perpendicular or normal. Normal is nothing but perpendicular to the contact support. This restrains, see, the motion of the body. If because of this self weight, what is the motion, direction of motion of the body? This is the direction of motion of the body. So what this support is doing? This support is restraining the movement of the body. This movement of the body is perpendicular or normal to this surface, then it is called as a simple support. Here keep in mind, we are ignoring friction. See here, this support is also simple support. See what is happening, this roller is just touching the support. We may take it as a, let us take this as a wall. This wall is supporting this circular ball. The weight of the ball is acting in the downward direction, and if I remove this support, what happens? This ball will start to move in this direction, just like a pendulum. So this wall is supporting this. What it is doing? It is just obstructing the movement in the direction normal to this. This is the normal movement, right? This is the contact surface. The movement is the movement. There is a difference between, kindly remember this word, whatever now I am telling is movement. The movement of this body, like if it is a pendulum, if I consider this as a pendulum, what happens if a pendulum is there? If I allow it to move, move it will move in the to and fro action. If I give a support here, that is I am stopping its motion, so the motion is exactly perpendicular or normal to the contact surface. So remember this, always the support reaction. See here, this is the support reaction developed here. Always the support reaction is perpendicular to the contact surface. Okay, this is the contact surface. To this contact surface, the reaction developed is normal here. So this is called as a simple support. Next, this is an example. So this is a table lamp. This table lamp is rested on this table. So this is a simple support, though this table lamp is not falling on the ground because of this table, and the reaction developed is perpendicular to the contact surface. This is the contact surface, and the reaction developed is perpendicular to this contact surface. So this we are considering as a simple support. So only the motion of, let us see, this table lamp is not allowed to fall down. That's it. I can move this table lamp in this direction, I can move this table lamp in this direction, I can lift this table lamp, or even I can rotate this table lamp. But only thing that is restrained is it is not allowed to move perpendicularly downward direction. That is the motion in the direction, that is a motion that is perpendicular to the contact surface is restrained. That is called as a simple support. Next is the roller support. So what is a roller support? Rollers are placed at the support. So in a simple support, what we are doing, let us take, this is a table over which an object is placed. This is simple support. Instead of this, if I give some rollers here, on that if I place a body like this, let us take, let me draw this one. This is a table over which few rollers are kept. Upon that a body is placed here. Okay, so what happens here? The body is free to move in this direction. Okay, the to and fro motion is allowed, and even I can lift this body, or even I can rotate this body. But only thing that is restrained is again the direction, that is perpendicular motion about the contact surface is restrained, but the body is allowed to move in to and fro direction. These rollers will make the motion bit easier, that is friction is reduced here. Rollers are placed at the support, restrain movement of the body in the direction normal to the contact surface. This is the contact surface, and the motion, that is this object will not fall in this direction, that is the motion in the contact perpendicular to the contact surface is restrained. Okay, so see here, what is the support reaction? The reactions developed are always perpendicular to the contact surface. Here this is the inclined contact surface. The reaction developed is perpendicular to this contact surface itself. This is the symbol of a roller support. To show anywhere, if you want to show a roller support, you have to symbolically represent it in this manner. Next is, so let us take an example, day-to-day example. See here, this is a wardrobe. See here, here we will be, this is a sliding kind of a wardrobe, right? So what happens, I can slide this in to and fro motion. This door is slided in only in to and fro motion. I cannot move it in upward direction because here the rollers are given at top and bottom, right? Because of which a reaction because of which because of these rollers upward motion is restrained, because of these rollers downward motion is restrained. Only thing what I can do is I can move this in to and fro motion. This is where the roller support is useful. So there is a question arises, what is the why we are providing roller? Simply simple support is there and roller support. If I provide a simple support, what happens, it becomes difficult to move this body or this door in to and fro motion. If I provide rollers here, what happens, this will move easily, that is this door will be closed and opened easily. This is the day-to-day life example for a roller support. Okay. Next is a hinged support. Support which resists or restrains translation movement. Translation movement is nothing but the motion in horizontal direction and vertical direction are called as a translation movement. Support which restrains or resists translation movement but not rotational movement. That is, rotation is allowed. A body is allowed to rotate, but it is not allowed to move. That is in the horizontal direction and vertical direction. Translation movement is restrained, but rotational movement is not restrained, is called as a hinged support. Support which resists or restrains translation movement but not rotational movement is called as a hinged support. The direction and the magnitude of the support reaction depends on the direction and magnitude of the force acting. For example, let us take this is the hinged support. If I apply load in vertical direction, only vertically downward load is acting here, then support reaction developed will be exactly vertically upward. If I apply only a horizontal moment, then the support reaction developed will be in horizontal motion, horizontal direction only. No vertical support reaction will develop. If I apply vertical force and horizontal force, then only support reaction developed will be vertical and horizontal, because translation movements are restrained here. That is, the body is not allowed to move in horizontal direction and move in vertical direction is called as hinged support, but it can rotate about this support. If I lift it, if I try to lift it, what happens, if the body starts to rotate like this about this support, then it is called as a hinged support. So at hinged support, what are the restraints developed? One is a vertical restraint and another one is a horizontal restraint. In simple support, only the support reaction developed is perpendicular to the direction of a contact surface in both simple support and hinged support. But in both simple and roller support, the reaction developed is perpendicular to the contact surface, and in hinged support, the restraint developed are vertical and horizontal restraints. So in hinged there are two restraints. Okay. In simple support and in roller support, only one restraint is there. Okay. Only at the about the contact surface, the movement is stopped. Two restraint, that is horizontal and vertical motion of the body are restricted. Only rotation is allowed. Then it is called as a hinged support. Next, let us take a day-to-day example for this hinged support. So in the previous case, we have shown a wardrobe which was of a sliding kind of doors. Here the doors are of hinged type. Okay, if you pull, what happens? It will rotate, right, about this support, but you cannot pull out this door, or you cannot even move this door in upward direction or even in downward direction, or even you cannot pull it outside. But what happens, you can rotate about this support. This is the support, right, vertical support. Here hinges are provided, right. This is the day-to-day use of a hinge support. Hinge support is nothing but the support where vertical motion and horizontal motion are restricted, but rotational motions are allowed. Okay, this is the support. Here is the support. Here your door will rotate about this support, but your door will not move upward or downward direction, nor even horizontal, or any vertical and horizontal movements are restrained. But only thing, if the doors are allowed to rotate here. So this is the day-to-day example of a hinged support. Next, let us go for fixed support. So in this support, all the kinds of motions are restrained. That is, all the translation motions and all the rotational motions are restrained in all direction is called as a hinge fixed support. The so here whatever the reactions are developed because of this applied load and it is fixed here. One is what are the reaction developed? Vertical restraint, horizontally also it is restrained, and even movement will also develop here. Okay, because the body is not even allowed to move in horizontal direction, not even move in vertical direction, and not even it is allowed to rotate. Allowed to rotate means what happens? This is hinged at at hinge it was allowed to rotate. If I fix it that there is no rotation, so what happens here? Movement will develop here. So what is movement? If I fix it somewhere, if I apply some load here, force into perpendicular distance will give me the movement. Okay, the movement is developed here, and vertical and horizontal components are restrained. Then it is called as a fixed support which restrains or resists translation moment and rotational moment of a member in any direction is called as a hinged support. The direction and magnitude of the support reaction depend on the direction and magnitude of the force acting. So see here, only if a vertical force is acting, support reaction developed will be one is vertical support reaction and another one is movement. If horizontal force is acting here, support reaction developed will be horizontal support reaction along with the movement, or momentum may or may not develop. If this force passes through the CG, there is no movement. If force is passing at a perpendicular distance, some distance is away from the CG, then there will be development of movement. If an inclined force is applied here, so inclined force is nothing but it has a vertical component and horizontal component, right? This inclined force I can resolve into horizontal component and vertical component. So therefore restraint developed at this point is one is a horizontal restraint. That is, because of this it is not allowed to move in horizontal direction. That is, this is a horizontal restraint developed here. Because of this applied load, this body is not allowed to move in vertical direction also, right? This is the vertical restraint. And because of application of these two, there is a movement developed. To resist that movement, a counter movement is developed here. This is the movement is developed. If both there is no horizontal, there is no vertical, and there is no rotation is developed, then it is called as a fixed support. With this, all the four kinds of supports with the day-to-day examples are given to understand those things. So kindly go through these things and remember the things. If definition or types of supports may be asked in the examination. So even from examination point of view also, these four definitions and these four names are important. Kindly remember the things properly. Thank you.